Why is reactive power, kVAR, vital for power factor correction? Imagine a busy highway where cars representing electrical current, and the traffic flow needs to stay smooth for everything to work properly. Now, think about what happens when some cars are just idling, not moving forward but still taking up space. That's similar to reactive power in an electrical system. Reactive power, measured in kilovolt-amperes reactive, is the part of electrical power that doesn't do useful work but is essential for keeping the system stable. It's like the energy needed to build magnetic and electric fields in motors and transformers. Without reactive power, these fields can't exist, and equipment won't run properly. In power systems and renewable energy setups, reactive power plays a big role. When you have devices like motors or transformers, they create magnetic fields that need reactive power to stay energized. If there isn't enough reactive power supplied locally, the system has to draw more from the utility. This extra draw increases the total current flowing through the wires, which causes more losses and wastes energy. It also makes the system less efficient and can lead to voltage drops, which can harm sensitive equipment. Power factor correction is all about balancing real power, which does actual work like lighting bulbs or running machines, with reactive power. When reactive power is high, the current is higher than necessary, even if the real power remains the same. This is where reactive power becomes vital. By adding devices like capacitors that supply reactive power locally, we can reduce the amount drawn from the grid. These devices are rated in kilovolt-amperes reactive, meaning they can supply a specific amount of reactive power needed by the system. Supplying reactive power locally helps move the power factor closer to 1, which means the current and voltage are more in sync. When this happens, the system runs more smoothly, with less energy lost in transmission. It also means the electrical infrastructure can handle more load without overloading. Utilities often charge extra when reactive power demand is high because it causes inefficiencies and extra stress on the system. So, fixing reactive power issues saves money and keeps the power flowing reliably. In power generation and transmission, managing reactive power is especially important. Renewable energy sources like wind and solar can cause fluctuations in reactive power, making voltage regulation tricky. Using reactive power correction helps stabilize voltage levels across long transmission lines, ensuring power reaches homes and businesses without issues. It also helps in avoiding equipment damage and reducing the need for costly upgrades to the grid. In practical terms, engineers calculate how much reactive power correction is needed based on the existing reactive power demand and the target power factor. They install capacitors or other reactive power sources at strategic points, near loads, at distribution panels, or at main substations. This way, they keep the system efficient, stable, and ready to handle the demands of modern power systems and renewable energy integration. So, reactive power in kilovolt-amperes reactive is vital because it keeps the electrical system balanced and efficient. Correcting reactive power reduces unnecessary current flow, improves voltage stability, and makes sure that the power system can serve everyone reliably and cost-effectively.